In this video, we're going to talk about a really problematic spontaneous reaction. So the spontaneous reaction that we're talking about is corrosion. And corrosion is an extremely expensive problem. Since most of our structures in in the modern world are built using steel, which main component of that is iron, corrosion or rusting is an extremely expensive problem. Now, corrosion and rusting costs a huge amount of money to repair and fix, but also to prevent it. And so, between lost productivity and loss of um, materials, it is estimated that it can cost up to 3% of the GDP per year. So, gross domestic product. So, that's a huge amount of money. That's a big tax on society. So preventing corrosion is really important. Before we talk about preventing corrosion, you should know that water and oxygen will react to make hydroxides, and that oxygen and acid particles will produce water. So in acidic conditions, this reaction happens, and when it's not acidic, this reaction happens. You can see that this is going to be an extremely strong uh, reduction reaction because it's got such a big positive value. And so acidic conditions really speed up corrosion, and so do salty conditions. And that makes sense if you consider that salt is an ionic compound, and that ionic compound is going to create essentially a saltwater bridge where it allows for the fast transfer of electrons. So here's a diagram here where you've got hydroxide ions in uh, and oxygen are reacting with the iron, and the iron becomes iron 2. That diagram is similar to one that's in my notes or from the textbook, where you can see that they've got a puddle of water here, and the puddle of water on the iron is reacting. The oxygen reacts to become hydroxides, and the iron is becoming iron 2, which gives off the electrons. So the water and oxygen produce hydroxides, and the iron becomes iron 2. And this creates a spontaneous reaction that is really problematic. So, how do we limit the amount of corrosion? So, corrosion um, is is first of all is made worse by acid, and so carbon dioxide in the air makes carbonic acid, nitrogen dioxide and sulfur dioxide increase acid rain, which further makes corrosion worse. um, Oxidation will occur on any metal below that on the list of the reduction half reactions. So what that means is that if we're looking on here, if we're looking at um, water and oxygen here, that any metal that is here is going to be oxidized by it because this is a spontaneous reaction. So this is a big problem that occurs for lots of metals. The biggest concern is obviously iron. Um, there are some metals that have a pretty cool result to this. So some metals like aluminum, when it corrodes, makes a layer of the corroded metal. Um, so if you get aluminum oxide, like on an aluminum can, if you scrape the aluminum can, it creates aluminum oxide and it adheres tightly to the surface of the aluminum can so that the aluminum can doesn't just keep oxidizing. If you had copper, it will create a metal carbonate, or silver makes silver sulfide. And so if you look at like an old copper building, it looks green because it's got this copper 2 coating. And if you have a silver ring, the silver gets coated in silver sulfide, which is is the tarnish, but it means that that metal underneath it is sealed up and it's protected. The same thing happens with zinc, but that doesn't happen with iron because iron oxide is porous and it bubbles up. So you get the iron flakes off and it just keeps exposing more and more iron as the metal flakes away from the iron. And essentially what it does is it traps the water in in the rust bubble. So if you look at an old vehicle, when it starts to rust, you'll see the paint getting bubbled away. Well, that brings us to a few of our simplest techniques for preventing. If we painted, greased, or oiled, plasticized, dipping, or galvanizing, or alloying, these are ways to reduce the reaction. But specifically, when we look at these examples here, these all are causing a physical barrier. So essentially, if the water never comes in contact with the iron, it can't corrode. So by creating a physical barrier, by painting over this, you're keeping the oxygen and water away from the iron, and it does not allow for the reaction to occur. So painting is the obvious one. If you look at any metal bridge, it should be painted. Some things can't be painted. So like if you were at an oil derrick, the moving parts are in the side of an engine, the moving parts would just wear off the paint immediately. But if you keep them greased, like in the engine, the pistons in an engine, the grease seals the metal off from the water and protects it. Now we will have things coated in plastic. So if you've got a plastic coating surrounding it, that creates a barrier. Dipping, I mean, that's just a different way of applying something to it. Galvanizing and electroplating, we're going to talk about how that process is done when we talk about electrolytic cells and soon. But essentially, galvanizing and electroplating creates a very fine coating of a metal on the outside of the iron. And so you can get a very thin coating of something that protects the iron. So galvanizing coats in zinc, and electroplating, you could pick a different kind of metal, but that coating on the outside of the iron will protect it. Different technique to prevent corrosion is cathodic protection. And so we're going to zone in on this because this requires a little bit of understanding about the redox that allows this to work. So ships or underground tanks made of iron are often protected by cathodic protection. In ground or water, the system is aqueous and contains salts. So the water in the ground has salts, so you know that rusting will occur. The iron will rust, and it can be prevented, though, if you can connect the iron to a metal that is more inclined to corrode. So this is called cathodic protection. And essentially the strategy is that if you've got a metal like iron, so we've got iron is here, if I could supply a metal that was below that, we can have that will react instead of the iron, right? Because if I connected my iron and I had magnesium, this is the strongest reducing agent. It's going to react instead of iron because this is a weaker reducing agent than the iron. So the cathodic protection creates a sacrificial anode where this magnesium is going to corrode instead of the iron. And what they do is they connect it so that the electrons are being taken from the magnesium instead of the iron, so that you get the magnesium solid becoming magnesium ions plus 2 electrons instead of having your iron solid becoming iron 2s plus 2 electrons. So this is sacrificed, and that's called cathodic protection. Another method that is used in metal or in automobiles and in large iron structures is or that is close to an electricity source, is that by connecting the iron object, you can supply direct current to the metal object and it discourages oxidation. So if you've given the iron, if you're supplying it with electrons, the electrons will continue through the iron, but it doesn't give the iron a chance to corrode. So you're basically um, supplying the electrons so that they're not needing the electrons from the iron itself. This must be direct current, so it can't be alternating current like from the that we get to our houses. It needs to be direct, and this is like a common strategy that they might use for something that is um, that is going to be difficult to protect in another way. Um, so, in another form of cathodic protection, bodywork of most family cars is connected to the negative of the lead acid battery terminal, and so the battery from the car will help to reduce corrosion. Um, so where gas lines are buried, like in alleyways, you'll find signs that look like the one that's shown here, and the current from the cable is directed to the iron gas main. These signs are usually attached to a modest-sized gray box. Housed in the box is an appropriate electrical hardwire to produce direct current from the alternating current of the main grid. So basically, they've got a little converter that is going to change the AC from outside that we get to our house into direct current, and it's going to protect the iron from rusting. And if we can reduce the loss of productivity by reducing corrosion, then we're saving money. So there are several different strategies for that. I would expect you know about the different kinds of coating, what a sacrificial anode is, and how you can supply direct current to reduce the amount of corrosion.